April is rolling along, and nuclear power is stepping up to power AI's big ambitions. Think steady energy for data centers and blockchain projects. But before we kick things off, we found that 60% of you aren't following us yet. Please do us a huge favor, hit that follow button, and collect our episodes on pods.media. Your support means a lot. Thanks, guys.
So we're diving deep today into why nuclear power is having this real resurgence right now.
Yeah, and particularly how it's all tied in with these huge demands from AI and blockchain.
Right, exactly. You sent in some really, really interesting stuff. And what we're going to try and do is pull out what we think are the most important bits of information and insights.
Totally. We've got articles here. They're talking about energy trends. We've got some crazy updates on different technologies. Yeah. Okay, so for anyone who's like, wait, hold up, what exactly is nuclear power? Let's start there.
At its heart, nuclear power relies on this process called nuclear fission.
Okay.
And what that means is you split the atom of a very particular type of uranium-235. And when you do that, it releases an incredible amount of energy. Really, really important to say this is just for electricity generation, nothing to do with nuclear weapons. Totally separate thing. Now, if we look at globally, nuclear power is contributing about 9% of the world's electricity right now in 2025.
Wow, 9%.
According to the World Nuclear Association. And just to give you a sense of the scale, the energy that you get from a really small amount of uranium is the same as burning tons and tons and tons of coal.
Wow.
So, that's another thing that's really driving this resurgence. It's just this incredible density of energy that you get out.
Yeah, okay, 9%, that is a serious chunk of the world's energy. So why is nuclear power relevant right now in 2025? What are the big advantages?
Well, there are a few things. I think first and foremost is its reliability. Unlike solar and wind, which are amazing in their own right, but are dependent on whether the sun is shining or the wind is blowing, nuclear power plants can run pretty much continuously. It means they provide a really stable and reliable source of energy. Okay. It's especially important when we talk about things like AI and blockchain. These technologies need constant power. And if the power cuts out, well, everything grinds to a halt. You can't process data. You can't verify transactions. Nuclear power, because it's always on, it basically de-risks the infrastructure. That's number one. Second big advantage is that it's low carbon, which is obviously a huge plus when we're thinking about climate change. And then the final thing is just the sheer power output. One large nuclear plant can generate enough electricity to power 1 million homes.
Wow.
So for you, I think those are the key takeaways about why it matters right now.
Sense. So we've got what it is and why it matters. Now, I think I need you to walk me through how it actually works. How do we go from splitting atoms to powering my computer?
So it all starts with a controlled nuclear reaction in a reactor. Okay. Essentially what happens is a neutron will strike a uranium-235 atom and it causes it to split.
Right.
Now when it splits, it releases more neutrons and a whole lot of heat. And those neutrons go on to hit other uranium atoms, causing them to split and so on and so on. It creates this chain reaction.
A chain reaction.
Right. And that's what generates the heat.
Yeah.
Now, this is all very carefully controlled.
I was going to say.
It's not just, atoms splitting all over the place.
Yeah.
And that massive heat that's generated, that's what we use to make electricity.
Okay, so we've got the splitting action going on, creating heat. What's the next step?
So that intense heat is basically used to boil water, and that creates high-pressure steam.
Okay.
And then that steam is used to drive these big turbines, which are connected to generators. And that's what ultimately produces the electricity.
Got it.
Now, a typical large nuclear plant, you're looking at an output of maybe 1 to 2 gigawatts.
Okay.
Now, to put that in perspective, that's enough power to run a whole city, or coming back to our topic, a massive AI data center. And all of this is happening constantly. And again, it's important to remember that these plants have all sorts of safety and control systems, and they're built to last for decades. So hopefully that gives you a better understanding of the mechanics of how it all works.
Yeah, for sure. Knowing that one plant can power a city, it's kind of mind-blowing.
It is pretty amazing.
And it really shows the potential, especially with these new technologies that just need more and more power.
Right, exactly. That's the key thing here. These AI and data centers are incredibly energy hungry. Goldman Sachs projected that just those two sectors alone could be using something like 9% of all U.S. electricity by 2030.
9%.
Which is huge. And not only do they need a lot of power, but they need it constantly. So for someone like you, if you're running some crazy simulation, you need to know that the power is not going to cut out in the middle of it.
Makes sense.
And that's where the reliability of nuclear comes in. Solar and wind are great, don't get me wrong, but they're not always there.
Yeah. The sun's not always shining.
Exactly. So if you need that guarantee of power, nuclear is really the only option. Plus, from an environmental standpoint, it's a good thing. Each nuclear plant prevents millions of tons of carbon dioxide going into the atmosphere every year.
That's a big plus.
And again, for you as a creator, A stable grid means you could do your thing.
Right.
You could deploy your AI model, you can run your blockchain network, whatever it is, without having to worry about the power cutting out.
So we're seeing that AI and blockchain need tons of power, and nuclear is a reliable way to provide that. But is AI also helping to advance nuclear power?
Yeah, it's interesting. It's not just a one-way street. AI is starting to be used to actually make nuclear plants run better.
How so?
So you can use AI algorithms to analyze all the data coming from the sensors in a plant.
Okay.
And you can use that to predict when maintenance is needed.
Oh, that's smart.
Which means less downtime, and it can actually reduce operating costs by something like 15%.
15%? That's pretty significant.
It is, yeah. A report from the Idaho National Laboratory in 2024 found that. And then, think about blockchain specifically. You could have AI agents powered by this stable nuclear energy constantly executing transactions on the blockchain. So it's really this kind of beautiful synergy between these two fields.
It is a pretty cool combination. So who are the big players making moves in this space? Who's investing in nuclear for their AI and cloud computing needs?
We're seeing a lot of activity, especially from the big tech companies. Microsoft is actually putting a huge amount of money, like $1.6 billion, into reviving the 3 Mile Island nuclear plant.
Wow.
Their goal is to have 835 megawatts of nuclear power up and running by 2028. Specifically to power their AI infrastructure. Google's also getting in on the action. They've partnered with Kairos Power to bring 500 megawatts online by 2030 using small modular reactors, which we can talk about a bit later. Amazon is also building their own small modular reactors in Washington state. Their plan is to have 300 megawatts of capacity to support their cloud and AI services. And even Meta is looking to get in on this. They put out a request for proposals back in December 2024, looking for somewhere between 1 and 4 gigawatts of power to fuel their AI expansion.
Wow, 1 to 4 gigawatts. That's massive.
It is. And it's not just the private sector. The U.S. Department of Energy is also working on transforming 16 federal sites into what they're calling nuclear AI hubs, which is interesting.
Nuclear AI hubs.
Yeah, so they're really pushing this clean energy aspect. And the key thing to remember here is that these are all active projects, not just ideas on paper.
So nuclear seems to be a major part of the future for tech. What about nuclear itself? What are the new developments we should be watching?
One of the most exciting areas is small modular reactors, or SMRs for short.
SMRs.
These are basically smaller factory-built nuclear reactors, usually around 300 megawatts.
So much smaller than a traditional plant.
Exactly. And because they're built in factories, you can deploy them a lot faster and more flexibly. There are currently about 60 SMRs in various stages of development worldwide, according to the World Nuclear Association.
60.
And Google, like we mentioned earlier, is thinking about deploying as many as 6 SMRs by 2035.
Okay.
Then there's fusion energy, which is still a long way off, but there's a lot of research and development happening. Bill Gates' company, TerraPower, is doing some really interesting work in this area. And on a national level, the U.S. government has a goal of tripling the country's nuclear power capacity to 300 gigawatts by 2050.
That's ambitious.
It is. But it really shows how seriously they're taking nuclear as a key energy source for the future.
Okay, so we've covered a lot of ground. Can you sum up, what's the big takeaway here?
The big picture is that nuclear power is shaping up to be a really important solution for powering AI, especially with how much energy it needs and how consistently it needs it. Renewable energy will definitely be a part of the mix, but for that constant, reliable baseload power, nuclear is really in a class of its own. Some experts are even predicting that as many as half of all data centers could be running on nuclear power by 2035.
Wow, half of all data centers.
Yeah, it's a pretty big deal. And for creators, it means having a really stable and reliable platform to work on.
Right.
Whether you're minting your 100th podcast episode or building some crazy new blockchain application, you can be confident that the lights will stay on. Now, we do need to be realistic about the challenges.
Yeah, of course.
Things like nuclear waste disposal and the potential for cost overruns on these big projects. Like the Vogtle plant, for example, which ended up costing $17 billion more than originally planned.
Yikes.
Yeah, but if the development of nuclear, and especially SMRs, continues to move forward, it's possible that we could see nuclear powering something like 30% of all creator technology by 2030.
That's incredible.
Yeah, so a lot of potential, but some real challenges to overcome as well. Which leads to a question for you to think about. As AI and blockchain keep growing, and they're going to keep growing, what are the trade-offs we need to make as a society, environmentally, socially, as we scale up nuclear power to meet this demand?
It's a big question for sure.
It is, and it's one we all need to be thinking about.